Hello, it's time for another installment of Monoprice Mod Mondays. I'm Brian, and you're watching ADVi3D. We're going to replace that boring old firmware with something new, fresh, exciting. What is it? It's ADVi3 by Sebastian and ADVi3. This is a fairly significant upgrade. While the stock firmware is based on Marlin 1.1.4, Sebastian's ADVi3 is based on Marlin 1.1.8 and offers a lot of useful features. It has redesigned screens on the LCD, it can display live temperature graphs, it has 3 adjustable preheat presets, it has 5-point manual bed leveling, and supports PL Touch automatic bed leveling. It also allows you to tune the X, Y, Z, and extruder motors right from the LCD. Now, it's important to note that we're working on version 1 of this printer, the one without the automatic bed leveling. This firmware does not currently work with the newer printer, although it will be supported in a future release. Note also that this probably voids your warranty. That's kind of expected though whenever you're making modifications. Now, I've got a little bit of a rant here. Keep in mind that Monoprice's answer to any warranty issue at all is to have you send your printer back to them for evaluation, where they decide whether to repair it, replace it, or deny coverage. In the first 2 scenarios, you're responsible for shipping and insurance costs shipping the printer to Monoprice, and in the last scenario, you're responsible for shipping and insurance costs twice to get the printer back to you. That's why many users will opt to replace or upgrade parts on their own. I voided my warranty when I replaced a bad part cooling fan, and I made that decision based on the fact that I could get a fan from Amazon for like $5 and have my printer working within a couple of days, or I could spend like $50, send it to Monoprice, and be down for a couple of weeks. So now that I've got that out of my system, there's actually 2 things that we're upgrading the firmware on: the printer's mainboard and the LCD panel. And you might not know it, but that LCD panel is actually a little computer. It communicates with the mainboard over a ribbon cable. When you're controlling the printer from the LCD and pushing the buttons, it's actually sending G-code to the mainboard to carry out those commands. Upgrading the firmware on the mainboard is done with octoprint, which transfers the firmware to the mainboard via USB. And upgrading the firmware on the LCD panel is done by putting the upgrade files on a micro SD card with a capacity of 8 gigs or less, and inserting that card into the side of the LCD. To access the micro SD card slot on the side of the LCD panel, we're going to have to remove the bottom panel from the printer. And the frame around the back of the LCD panel may or may not have a cutout to let you reach the micro SD card slot. If it doesn't, you may have to take the front of the printer off to reach it. And since we're probably going to have to remove the front of the printer to get to the LCD panel's card slot, we may as well take advantage of that situation. So we're also going to install a printed upgrade to improve access to the LCD. This part brings the LCD out of the body of the printer and holds it at an angle. I don't know about you, but when I'm standing in front of the printer, it can be difficult to see what's on the LCD and accurately hit the buttons. By angling the LCD, it's easier for me to use, and plus this makes accessing the micro SD card slot on the side of the panel a lot easier. The printed part is from Thingiverse, and it's thing number 2369322. We're going to print this and install the part before we do the firmware upgrades. So let's go ahead and download the LCD enclosure. Let's go ahead and slice that file using Cura. Import that. And we're going to need some supports because there's some long horizontal areas here that can't just print in thin air very well. Okay, so I've got the supports turned on because I'm going to want to support the front of the opening for the LCD. I'm less concerned about the back of it, because that will recover. There's enough material there for that to recover on its own as it's bridging. This should do what we need it to do, so we'll go ahead and save this file out. And then we can start that file printing.
Now we can work on accessing the LCD panel, which is behind this metal plate here. The LCD is connected via this ribbon cable, and there is a little latch that you can pull toward you to release pressure on the cable, and then the cable will lift out of the connector. With that connector unplugged, I'm going to tip the printer back and set it on its feet upright. We're going to need to loosen the set screws that hold the smooth rods in place on the front, here and here, because we're going to remove the screws that hold the front panel in place, here and here. So we'll start by loosening those just a bit, and really just about one turn is sufficient. Now remember, we disconnected the LCD cable inside the printer. So this front assembly will now come off. 4 screws hold the protective plate on the back of the LCD enclosure. We will remove those. And that lifts straight off. And there's our LCD. Now we're going to mount this in the enclosure that we printed. And there it is. There's one little spot here where you can insert a small screw. If you've got some M3 screws, you can put a little one right there, and that'll hold the LCD in place in the enclosure. There we go. Now we need to mount this enclosure to the front of the printer frame. And this will involve us removing 2 screws here and here. We'll replace these with some M3x12 screws. We're going to reattach that metal cover where the LCD panel had been. You can leave it off if you want to, but then you've got this area here that's sort of exposed down into the inside of the printer, and you don't really want that. Now it's time to get the front of the printer. We'll line the smooth rods up with their holders and get everything slid into place. Then we will attach the front with its screws again. Get those tightened. And then we can tighten the set screws on the smooth rod holders. With the panel mounted back to the front of the printer, it's time to reattach the LCD cable. That will simply slide back into place. and then you bring that little latch back to the original position. Now it's time to reattach the base plate on the printer. And there's really only one way that this base plate goes on. Here's the notch for the Y carriage stuffer. Remember, the 4 longer screws go on the corners, and the 2 shorter screws go in the middle. So now we need to install a firmware updater on octoprint. And in order to do that, it has a couple of requirements, and that is that this software AVR needs to be installed on the octoprint machine. That's our Raspberry Pi. So let's go ahead and get that set up. So we'll initiate this connection from terminal. We'll use the SSH command to open a secure shell to the Raspberry Pi. And we need to specify the username that we're connecting as, and that's Pi, that's the default name. And the machine name, octopi.local. That's the same name that you connect to in your browser in order to control the Raspberry Pi or the octoprint instance. Now we'll go ahead and use the default password for this unless you've changed it. You may have. If you haven't, the default password for the Pi user is Raspberry. Now that we're connected, we're going to need to execute these 2 commands to get AVR installed. So we will type sudo apt-get update, and we will enter our password, which again, if you haven't changed it, is Raspberry. And we'll let that do its thing. Once that's finished, we'll execute the second command, sudo apt-get install AVR. And it'll ask if we want to go ahead and install this, and we will say yes. And the software will be downloaded and installed on the Raspberry Pi. And that's it. You can confirm the installation with the command which AVR, and this will tell you the directory in which AVR has been installed. Now we can exit this connection. Now we can install the firmware updater in octoprint. We'll go to the plugin manager. To add plugins to octoprint, when you're in the plugin manager, click Get More, and that will take us to the plugin repository where we can search for plugins. We'll search for the word firmware, and we want this firmware updater right there. So we'll install that. Once that's done, we'll need to restart the octoprint server. And here's our restart command. So now that we have the firmware updater in place on octoprint, we can download the 2 pieces that we need for the firmware update. We need the mainboard firmware and we need the LCD resources. And I've got links to those down in the description. So the first thing that we're going to download is the LCD resources. We're going to get the zip file and we're going to download that, and then we're going to unzip that and copy the files over to the micro SD card for the LCD. So here I have a micro SD card, 8 GB in size, formatted as a FAT32 volume, and here are the contents of that zip file. So we'll simply copy those and wait for them to finish. Alright, with that done, we can eject that card. I'm setting that aside. The other thing that we need is the hex file to flash the firmware on the mainboard.
Since I don't have the BL Touch installed, I've purchased one, and that'll probably be our next video, is installing that BL Touch. But for right now, we're going to use the non-BL Touch version of the firmware, and that's this one, the ADVi3 mainboard 3.0.2 hex file. So we'll download that, and that's the file that we're going to use with the firmware updater plugin on Octoprint. So in Octoprint, click the settings icon, and look down in the plugins section on the left, and there's firmware updater. That's what we installed earlier. We'll need to configure it just a little bit. We need to specify a flash method of using AVRDude because that's what we have installed. We need to specify the MCU as an ATmega 2560. And the path to AVRDude was /usr/bin/AVRDude. And the programmer type is wiring. Click Save, and now it's configured. Here we're going to browse for that hex file that we downloaded a moment ago. I'm flashing the mainboard first, and then I'm going to update the LCD. And the reason that I do that is, if you update the LCD first, it will look like it hangs after the update because it can't communicate properly with the mainboard. So we're going to update the mainboard's firmware first, and then we will install the LCD resources through that micro SD card. So I'm going to click Flash from File, and that's going to begin the flash. And I'm going to cross my fingers that it doesn't blow up my mainboard. Don't want it to be bricked. But that right there tells me that the flash was successful. Now the printer's trying to restart and the LCD is hanging. So what we're going to do now is update the LCD. I have my micro SD card, and we're going to insert that into the side of the LCD panel. Powering off first, of course.
Insert the card into the micro SD slot on the side of the LCD. You'll probably want to use tweezers because that connection is still kind of deep down in there. With the card resting in the slot, you'll need to push it in the rest of the way. It's the kind of connector that you push to set and push to pull back out as well. Then with the card inserted, turn on the printer, and it'll begin to update the LCD resources.
Well, now that we've got that firmware installed, I think I'd like to take advantage of that. With the minor extrusion issues that I had printing the LCD enclosure, I think I'd like to check the E-steps and make sure that my extruder is calibrated properly. This lets us do that. So we'll start by going into the tuning menu and going to extruder. Now it says to measure 120 millimeters of filament above the extruder and set a mark, as shown in the picture. I've got some white filament loaded, a ruler, and a Sharpie. Let's get to it. Sorry about the camera angle, but I've measured 120 millimeters of filament, and I put a mark right there. So we'll continue, and once the extruder has heated up, it will start to feed filament. And I've sped this up just a bit. Got to pull that filament along. Now when it's done, you're supposed to measure the amount of filament that's left above the extruder. I measured, and I got exactly 20 millimeters. If the value was different, I could have adjusted it here. You can either set it a little higher or a little lower, and then when you're done, go forward
and then hit the check mark to accept the values. And that's it. Okay, so this one was a little bit more complicated than the last one. We had several things that we needed to do. We needed to download and print an enclosure for the LCD. We needed to download firmware for the mainboard. We needed to download resources for the LCD. We needed to install some firmware update plugins and associated software on the Raspberry Pi. But once we had all that stuff in place, we were able to very easily get the firmware and the LCD resources updated. If you've got any questions about the process, leave a comment down below and I'll do what I can to help you out. Okay, there are a lot of links down in the description, so you can get the LCD enclosure from Thingiverse, you can get the firmware files, the LCD files, and the ADVi3 user manual. If you haven't subscribed yet, please consider doing so, clicking the BV3D icon right over here. There should be a nice video over here for you that YouTube thinks you might want to watch. And there are channel support links down in the description as well. Thanks for joining me for another Monoprice Mod Mondays, and I'll see you next time.